Greetings to all of you. This course on fundamentals of power electronics focuses mainly on the power converters and its components. This is a rerun course. Actually, it started in 2018, Jan semester. We are rerunning this course. The syllabus is almost similar, but we have included some updates. The first 3 weeks is updated very much. The first 3 weeks will focus mainly on the device. See, power electronics is highly dependent on the power semiconductor switches, and they are very, very important components, and they are central to any power electronic converter design. Therefore, the first 3 weeks will give you insight into the various switches like the diodes. The diode, its static and dynamic characteristics, how we modulate, and then comes the BJT, the bipolar junction transistor. Its static and dynamic characteristic, you have to understand it really well if you have to design the power converters. And then followed by, in the 3rd week, MOSFETs and IGBTs. There are several new devices also in the market. The high electron mobility transistors, HEMT devices, we will not be discussing it, but where you will get the feel for how to go about looking for what type of characteristic, what parameters you have to look for, so that you will be able to design even new devices from the data sheets later on. So these devices, the diode, the bipolar junction transistor, MOSFETs and the IGBTs are the most popular power semiconductor devices in the market today, and you will be seeing it in almost most power electronic converters as components. Then followed by that, we will go into the applications one by one. So first, AC to DC. The rectifier capacitor filter circuit is one of the most popular, volumetrically efficient topologies that you will see in most products, though it may not be the best in terms of EMI rejection, conducted emission, but this is a very, very popular front end for most power electronic components. So rectifier capacitor filter will be followed by protection and power factor. An idea of power factor, what it means, because the rectifier capacitor filter circuit, which is most popular, has lot of issues. One among them is the power factor. It has very low power factor. How do we improve power factor? How do we use topologies which give you a much better power factor? These are issues that will be discussed in week 5. And in week 6, we will touch upon the DC-DC converter linear. You may be surprised, but the point is that there are several circuits where linear regulators are required, and you should be conversant with the linear regulators too. Then followed by that will be the DC-DC converters, switched mode converters, and they will need the power electronic switches, the power electronic semiconductor switches and devices, which will be operated in the on-off regions only. Whereas in the case of the linear circuits, the power semiconductor devices are operated in the linear region. In the case of the switched mode converters, the power semiconductor devices are operated in either the full on or full off region. You will then come on to the week 8, where we will discuss the forward and the flyback converters, the isolated converters, the ones which you will see are commercially popular. And when you are discussing about the isolated converters, you will discuss about the inductors and the transformers. And week 9, we go slightly in depth into the design of the inductors and transformers, crucial components, critical components in any power electronic converters. And then we talk of the push-pull, high bridge, half bridge and the full bridge converters, the higher power side converters, and we also will be including simulation examples. And then in week 11 we will be covering a very important topic called the drive circuits. There are several ways you can drive the BJTs and the MOSFETs and the IGBTs. We will be spending one full week on discussing the drive circuits, non-isolated and isolated drive circuits, and discuss the various merits and demerits. And in that week we will also touch upon something called snubber circuits, which will kind of ease the tension or ease the stress on the power semiconductor devices. How do we go about do that? Finally, week 12 we will conclude with closed loop control. Almost all the applications will need closed loop control for regulation. So how do we go about doing that? So there are voltage control and current control, and both these will be touched upon to give you a flavor of a complete power electronic converter. So this is generally what the topics will be in this 12-week course. All these topics have been recorded. The video have been recorded in 2018. Most of them, there will be updates in the sense that the first 3-week topics will be updated, and also simulation we are using ngSpice. It's an open source simulation software, circuit simulation software. So we will continue to use ngSpice here too. Only change will be in the graphical user interface. In the recorded videos of 2018, we had used GEDA, GSHEM. It's also an open source graphic user interface GUI based schematic capture, and that was that schematic which was captured was converted to netlist, and ngSpice was used to do the circuit simulation. As that is not much supported, we will migrate to KiCad as the schematic capture front end. So we will capture the schematic using KiCad. Then with the captured schematic we will generate the netlist from KiCad, and that netlist will be passed on to ngSpice for further simulation. So that is the change in approach that we will be using. I will be including some videos which will give you this change in the simulation scenario. And I hope you will enjoy the 12 weeks that we will go through in the semester, Jan semester. Have fun. Thank you.